Welcome back, everyone. Today we focusing on quadratic pattern. It's been a while since I posted a video, but guys, I'm back now. Now I'm back. So, moving today, guys, we're coming with the 5 video. So just make sure that you have your pen and the paper there with you. So, question 4, 4.1. The following number pattern is given. We have 13, 27, 45, 67. 4.1.1. 4.1.1. Is this a quadratic number pattern? Justify your answer with relevant calculations, right? So a quadratic pattern has a second difference. So we need to find we need to actually determine whether this pattern here has a second difference. If it has a second difference, then we can conclude to say it is indeed a quadratic pattern. So we are given what? 13, 27, 45, as well as 67, right? Now let's find the first difference. We need to find the first difference. So we need to say T2 minus T1. So T2 minus T1, that's 27 minus 13, we get 14. And 45, that's T3 minus T2. 45 minus 27, we get 18. T4 minus T3, that's 67 minus 45, we get 22. So this is our first difference. Don't get confused. Now we need to find the second difference. T3 minus T2, we get 4. T2 minus T1, we get 4. So now we get our second common difference. If you can check, our first difference is not common, but our second difference is common. So now we can conclude and say, therefore, this pattern is a what? Is a quadratic. This is a quadratic pattern. This is a quadratic pattern, right? Or you can say, yes, it is a quadratic pattern because there's a second common difference. There's a second common difference. Perfect, right? So we're moving now. Let's go to question 4.1.2. Determine the general term Tn of the quadratic pattern. So the standard formula for the general term of quadratic pattern is as follows. We have Tn being equals to an squared plus bn plus c. So the only thing that you actually need is the value of a, the value of b, as well as the value of c. Are we still following? Okay, cool. Now let's continue, my good people. So now we need to say, okay, 2a equals to something. 3a plus b equals to something. As well as a plus b plus c equals to something, right? So 2a. So we will move from this point going up, right? What do I mean by that? 2a is equals to 4, right? 4, right? 3a plus b is equals to 14. 14, okay, let me use a different color so that we can understand. 14, right? Different color. A plus b plus c is equals to 13. So we have 13 there. I hope we are following, all of us. So the only thing that you need to do now is for you to divide both sides by 2. Both sides. And then the value of a is what? 2. Where we see a, we substitute 2. So we have plus b equals to 14. And therefore 6 plus b is equals to 14. Therefore b is equals to 8. Perfect. And therefore where we see a, we substitute 2 plus we have 8 on b plus c equals to 13. These two, they give us 10 plus c equals to 13. Therefore c is equals to 13 minus 10, that's 3, right? So now we need to find the quadratic, actually the general term for quadratic, right? So now we need to say Tn. Now we're plugging in the information. Tn is equals to a n squared plus bn plus c equals to our a, 2, n squared plus 8n plus our c is 3. You got your full marks. Now 4.1.3, let me just write it here. Allow me guys to actually write 4.1.3 there. Now calculate the value of t100, right? So now let me explain something. If you can check here, we have tn, right? But now we are having t100. So in place of n, now we need to substitute what? 100. So that's perfect. On which formula? On the formula that we got, right? Which is the quadratic general term, right? So Tn is equals to 2n squared plus 8n plus 3 equals to, so now we have 200 squared plus 8, we have 100 there, plus 3, right? Now let's find our final answer there. So plus 100, 3, and we get 20803. That's T100. T100. We are done for today, guys. This is your tutor from Teach Me Now. Signing out.